Hello, students. I am Mansi Agarwal, Assistant Professor, ABES Engineering College, Ghaziabad. Today, we will be discussing our next topic of data structure, that is merge sort. In the previous lectures, we have already discussed various searching and sorting algorithms, including bubble sort, insertion sort, and selection sort. So merge sort algorithm works on divide and conquer approach. This algorithm divides the input array into two subarrays recursively and sort these subarrays and then merge them to get the sorted array. This process is repeated until the entire array is sorted. So in order to understand the merge sort algorithm, let us first understand what is divide and conquer approach. So suppose if we have an unsorted array of 8 elements. So in order to sort this with the help of divide and conquer approach, we will first divide this problem having 8 elements into a subproblem having 4 elements each. And again, we will divide this problem into the subproblems having 2 elements each. And we will keep on dividing these subproblems till we will have one element left in each subproblem. So we will have only one element left in each of the array. And then we will start conquering. That is, we will then merge these two arrays such that the resultant array is sorted. Again, we will merge these two elements such that the resultant array is sorted and so on. Again, we will merge the arrays having two elements each such that we will get a resultant array having 4 elements. And then we will merge these two arrays having 4 elements each such that we will get our final sorted array with 8 elements. So let us now try to understand how the above mentioned elements will be sorted with the help of merge sort. So for this, these elements first will be divided into two halves, right? Suppose we have this array having elements 140, 25, 90, 110, 80, 98, 40, and 30. This will be divided into two halves, having 4 elements in each half. This will be 140, 25, 90, and 110 will be stored in one array. Recursively, we have to call the merge sort. And then 80, 98, 40, and 30 will be called separately. Again, this will be divided into two smaller parts having 2 elements each. This will have 140 and 25, and this will have 90 and 110. And again, here we will have 80 and 98. And the another array will have 40 and 30. We'll keep on dividing these arrays till the point that each array will have only one element. So at this point, we can see that each element is storing only one array element. Similarly, 80 is divided as one part and 98 will be another part. Here 40 and 30. So now after dividing the original problem into smaller parts, now we will start conquering them. In order to conquer them, We will consider these as two sorted arrays and then we will merge them. And while merging, we will keep in mind that the resultant array should be sorted. So in this way, we will get 25 and 140 as the result of merging. And here we will get 90 and 110. Here we will get 80 and 98. And here we will get 30 and 40. Again, we will merge these two sorted arrays and we will get a resultant having 4 elements such that the resultant array will be sorted. So we will get 25, 90, 110 and 140. And over here we will get one array with 4 elements 30, 40, 80 and 98. Now we have to merge these two arrays and you can see that after merging these two sorted arrays, we will get the final outcome, which will be the final sorted array having the values 25, 30, 40, 80, 90, 98, 110 and 140. So we can see that the array is sorted. So let us now try to understand the first procedure in which we have to merge the two sorted arrays. So suppose we are taking this as the example. Let us take this as an example. So now suppose we want to merge two sorted arrays. Right? But the sorted arrays are only stored in the original array itself, right? But the two arrays have been divided with the help of beginning, mid, and end. So suppose if we have the values 25, 90, 110, 140, 30, 40, 80, and 98. So we are considering that the elements from beginning to mid form one array, one part of the array, and from mid plus 1 till end, mid plus 1 till end, it forms the second array. Now we have to sort these arrays and we have to store it back into the original array. Suppose the name of the array is AR. So for this, what we will do? We will first of all create two sub arrays, suppose with the name L and R, right? And both of them will have the number of elements equivalent to the number of elements from beginning to mid and from mid plus 1 to end, and one extra element to store infinity, right? So what basically we are doing is we have taken two arrays with size n by 2 plus 1, right? We have taken n by 2 plus 1. And what we are going to do is we are going to store these values inside the left and right array. So suppose L will become 25, 90, 110 and 140 with infinity as the last element. And right will be 30, 40, 80 and 98 and infinity as last element. And then we will keep on comparing each element of left with right, and whichever element is smaller, we will store that element back into the array started from beginning till end, right? So here we will need three variables. One is I for storing the index of L. The another one is J for storing the index of R. And another one is K for storing the index of AR, right? So we can write the algorithm for merging the two arrays as merge, having the parameters as array, beginning, mid, and end. Inside this algorithm, we will first find out the size of left and right arrays. For this, suppose N1 is going to be the size of L. This will be denoted by mid minus beginning plus 1. And similarly, N2 will be calculated as N minus mid. Now, with the help of these two numbers, we will now create two arrays with the name L and R. L will be declared with size N1 plus 1 and R will be declared with size N2 plus 1. First of all, we will store the values from beginning to mid inside L and from mid plus 1 to M inside R. So for this, we will put a loop for I is equals to 1 to N1 do L of I is equals to ARR of beginning plus I minus 1. And similarly, for J is equals to 1 to N2, we have to store inside RJ the value of ARR beginning from mid plus J. Afterwards, we are going to store infinity into the last element. This is just a theoretical concept, as we are going to store by comparing the elements of L and R. So we are considering that if L has found its last element, so that it is infinity, so that all the elements of R before infinity will be stored in the ARR array, right? And we know that in order to merge two sorted arrays, first we will store the elements. If we reach the endpoint of one array, then we will store the leftover elements of the another array using another while loop. So while doing the implementation, we will work on that concept, but here we are working on the algorithm and we are working on the theoretical concept, right? So afterwards, we will store infinity in N1 plus 1 in both the arrays L and R. So R of N2 plus 1 will also become infinite, right? Now, for merging, we will start merging by assigning I is equals to 1 and J is equals to 1. And for K, starting from beginning to end, what we have to do? We have to check if if L of I is less than equals to R of J, R of J. If this is the case, then ARR of K will store the value of L of I, and we have to increment the value of I. Else ARR K will store the value of Rj, and in this case we are going to increment the value of J. So this is the process of merging. Let us now quickly revise the merging process. So in the merging process, we have taken two variables, n1 and n2, where n1 is the size of the left array and n2 is the size of right array. With the help of n1 and n2, we have created two arrays L and R, and this plus 1 is taken to store infinity. Now we have to copy the content from the original array to these left and right arrays. And for this, we have taken two loops, where in the first loop, I is starting from 0 till n1, and we are storing in Li, we are storing the values of ARR. We are storing the values of ARR beginning plus I minus 1. And similarly, for j is equals to 1 to n2, we are storing the value of ARR mid plus j. Afterwards, we are storing infinity as the last element of L and R. And then, in order to store back all the elements in the original array in the sorted manner, we have taken I and j, and we have initialized these variables to 1. And then for k started from beginning to end, we have to check whether the element at the ith position in L is less than equals to the element stored at the jth index in R. If it is less than, then we have to store Li into ARRK, and we have to increment the value of I. Otherwise, we have to store the value of Rj into ARRK, and we have to increment the value of j, right? So this was the merge process. Now coming on to the merge sort process, in which we are dividing the original array into two parts, and then recursively we are dividing them into two parts, and then we are merging them. So for this, suppose the name of the algorithm is merge sort. All we need is the array and the beginning and end index. So for this, the first point is, till what time do we have to divide the array? Till what time do we have to divide the array? Till the time the sub-arrays are having at least two elements. Only till that time we can divide it. So if beginning and end are at the same element, that means there is only one element left, right? So till the time beginning is less than end, only till this time we can divide our array into the sub-arrays. We can divide our problem into sub-problems, right? So till the time beginning is less than end, we have to recursively call this merge sort algorithm with the array ARR and with the array ARR and beginning and mid, right? And mid. And for this, we have to calculate mid, right? For this, we have to calculate mid. So we can say that here, we can say that mid is equals to beginning plus end by 2, right? So for the first call, we have to call it with array, beginning and mid. And the second call will be merge sort, ARR, mid plus 1 till end. And after recursively doing all these two merge sort calls, we have to merge the resultant arrays. And for this, we will be needing array, beginning, mid, and end, as we have just seen earlier. Right? So this is the procedure for merge sort. Now, let us see the complexity of this algorithm. So, in order to analyze the time complexity of this algorithm, suppose it is represented by Tn. So here we can see that what we are doing, we are dividing the problem having n elements into the subproblems having n by 2 elements. So we can say that Tn can be written as T of n by 2 plus T of n by 2, right? Plus the amount of time required in order to merge the two arrays, two sorted arrays of n by 2 size, right? So we can see that if suppose we have these two arrays, these two sorted arrays, and we want to merge them, then we can see that we need n comparisons, right? N by 2 from here and n by 2 for this. So we need a total of n by 2 plus n by 2 comparisons. That makes it as n comparisons. So we can say that if we are finding out the time complexity Tn, wherein we are dividing it into subproblems of size n by 2, we can say that after dividing it into two problems, the merge algorithm will be done by n operations, right? Now, again, we can write it as 2 T of n by 2 plus n. Now, suppose again we are dividing this problem with the size n by 2 into two parts, right? So in this case, it will be 2 T of n by 4 plus T of n by 4, right? And the time required to merge these two arrays of n by 2 size. So this will require, again, this will require n by 2 cost plus n. Simplifying it, we can see that it becomes 2 of t n by 2 square plus n by 2 plus n, which can also be written as 2 square t of n upon 2 square plus 2n. Now again, we can see that if we divide this problem into two subparts, we will get 2 raised to the power 3 t n upon 2 raised to the power 3 plus 3n. Suppose if we say that after k divisions, suppose we say that after k divisions, if I say that the number of elements in the array is 1, the number of elements in the array is coming out to be 1. So we can say that Tn will become 2 raised to the power k T n upon 2 raised to the power k plus k dot n. Now, if we assume that 2 raised to the power k is equals to n, because we are saying that, we are supposing that n is a power of 2. N is, the number of elements is in the power of 2. So we can assume that 2 raised to the power k is equals to n, right? 2 raised to the power k is equals to n. So taking log on both the sides, we will get k is equals to log n. We will get k is equals to log n. Now we are going to simply replace these values. 2 raised to the power k can be replaced by n, and this will become t n upon n. So that means this will become t1 plus n, and k can be represented as log of n. Right? Now, in order to find out the cost of one element, this is going to be a constant time, which can be represented as c. So this is equals to c of n plus n log n. And as you know that in this expression, n log n is the dominating term. So this can be represented as theta of n log n. Right? So the time complexity in all the cases will remain theta of n log n. Now coming on to the space complexity. Now as you can see that in order to perform the merge sort, we have taken two arrays with L and R. Right? They are having n by 2 plus 1 and n by 2 plus 1 number of elements. So we can say that we have taken these arrays with n plus 2 number of elements. So in this case, the complexity will become theta of n. But other than these two elements, we have also used the recursion, and we know that recursion uses activation stack. So suppose if we see that we are calling merge sort algorithm for suppose 8 elements. So we are calling the merge sort algorithm for 8 elements. This will again call the merge sort algorithm for 1 to 4 and merge sort algorithm for 5 to 8, and then it will call merge for 1 to 8, right? So if we just make one activation record for these particular calls, the first call is merge sort for 1 to 8. The another one this call will be executed. So this will be stored as merge sort 1 to 4. And then again for this call, first it will calculate merge sort 1 to 2, and then it will calculate merge sort 3 to 4, and then it will merge it. It will merge the elements from 1 to 4. So for this now, the merge sort 1 to 2, the call merge sort 1 to 2 will be executed, will be stored in the activation record. And for this again, we will have merge sort 1 to 1, and we will have merge sort 2 to 2, and then we will have merge 1 to 2, right? For this merge sort, 1 to 1 will be stored in the activation record. Now, after this, there will be no more recursive calls, and this merge sort 1 to 1 will be executed. And in place of this, we will get the next call, that is merge sort 2 to 2, right? Again, for this, there will be no recursive call, and this will be deleted from the activation record. And then we will execute merge algorithm, that is merge 1 to 2, right? After doing merge 1 to 2, after completing this operation, merge sort 1 to 2 is executed. Now this will be replaced by merge sort 3 to 4. So we can see here that the maximum number of activation records that are formed will not be more than log n plus 1. They will not be more than log n plus 1, right? So as earlier, we computed the space complexity having the maximum order of n, and from the activation record, we have computed the space complexity as log n plus 1. So the dominating term among these two is n, and hence the space complexity will be represented by theta of n. So the time complexity for merge sort is n log n, and the space complexity for this algorithm is theta n. Let us now implement this algorithm with the help of VS Code. The first procedure that we are going to implement is merge, as it has been discussed in the algorithm. This merge procedure, this merge function, will have the parameters as array. Then we will have beginning. Then we will have mid. And we will also have end, right? Inside this function, first we have to find out n1. We have to take two variables, n1 and n2, and the value of n1 will be given by mid minus beginning plus 1, and the value of n2 will be given by end minus mid, right? Now we will declare two arrays with the name L and R. L will have the number of elements as n1, and R will have the number of elements as n2. Plus 1 is not required here because we will not be storing infinity as the last element, right? Now we have to store the values from the original array into these left and right arrays. For this, we have taken some variables like I, j, and k. So for I is equals to 0, I is less than n1, I plus plus, we have to store the values in L of I as ARR, beginning plus I, right? And in the similar way, for j is equals to 0, to j is less than n2, j plus plus, we have to store the values in right array. So for this, we have to write Rj is equals to ARR mid plus J plus 1. Now, after storing these values, we have to now, these two L and R have been formed having sorted values. And now we have to merge them back into the original array, that is ARR array. So for that, we have taken I is equals to 0, J is equals to 0, and K is equals to beginning. Right. Now, while I is less than N1, I is less than N1, and J is less than N2, we have to see if L of I is less than equal to R of J. If it is so, then we have to store the value of L of I into ARRK, and we have to increment the value of I and also the value of K, which can be incremented afterwards. Else we have to store ARRK as R of J. And in this case, we have to increment J. And in both the cases, afterwards, we have to increment the value of K. Right? Now, for the leftover values, for which theoretically we have assigned infinity into L and R, but here we are not going to do it. Rather, we have to simply copy the leftover elements either from L or from R to ARR, right? For this, we have to check if I is less than N1, means I have not been reached till N1. In this case, we will store the value of L into ARR. So L of I will be stored in ARR and both these values will be incremented. So I will be plus plus and K will be plus plus. And otherwise we have to increment, we have to see whether J is less than N2. If J is less than N2, then ARR K will be assigned as R of J. And in this case, both J and K will be incremented by 1 in this way. Right? So this is the algorithm. This is the implementation for merge procedure. And now coming on to merge sort procedure. So in order to merge sort, we have to take an array. Then we should know the beginning and we should know the end. Right? And in this, we have to check whether beginning is less than n or not. If it is so, if it is less than the end, then we have to take a middle value and we have to compute this middle value by adding up beginning and end and dividing this value by 2. And then we have to call the merge sort recursively again for ARR, and beginning till mid, and then we have to call merge sort again with ARR mid plus 1 till end, and then we have to merge them. And in order to merge them, we need beginning, mid, and end. Right? Now coming on to the main function, void main, we can here declare any array which is not in sorted form. Suppose I'm taking these 8 values. Now let us compute the size of this array with the help of size of operator. So we can write size of ARR and we can divide this value with size of any one element, that is, we can take ARR 0. And then we have to call the merge sort algorithm with this ARR, comma, the value of beginning will be 0 and the value of end will be n minus 1, right? Afterwards, we can display the content of the sorted array. So we can say that the sorted array is for int I is equals to 0, I is less than n, I plus plus, we can display the content of the array. So let us run this code. So as you can see that after running the code, we have got the array which is sorted. So hence this is the implementation of merge sort. The references taken for this video includes Tenenbaum, Langsam and Augustine's data structures using C, Horowitz and Sahani's fundamentals of data structures, Shom's data structures, and Thareja data structure using C. Thank you.